until 10th, I think, 15th or something.
And sine of 0 is
Yeah,
0. Yes, from this coordinate I can say that. Now from this coordinate what can we say? Can you tell me? The coordinate here is 0 comma 1, right? What's the angle at this
yeah.
point? You are at this point, what's the angle?
Mm. So 180.
Angle is measured from where?
Which angle?
There's only one angle.
Which
There's
one?
only one
Can you
angle.
mark which one are you talking about?
The angle that's measured from the x-axis. There's only one angle that's being
Okay.
measured. I'm talking about this angle. So if we move ahead, somewhere it is in here. When it comes here, what's the angle? Angle. What is
Oh
theta?
yeah,
What is
it's
theta?
co cos wise cos or something.
What is this theta?
Theta's
Where is theta?
cos
Where is theta being measured from?
wise from the x-axis.
Yes. And what is this angle then? What is this angle? When your pointer is here, your line is here. What is
90.
that's what I'm asking. What's the angle? 90.
Okay.
And what
Yeah.
that means cos 90, 0. Sin 90, 1. This
Yeah.
coordinate minus 1 and 0. Tell me, from here what can we conclude? What's the theta?
For which one?
This point, from this point.
Yeah, it's so 180.
So that means what is cos 180?
Cos 180 is minus 1.
And sin 180 is
It's 0.
if we come over here, what's the theta?
It's 0.
Here theta is 0.
Theta is 270.
And what is the coordinate of this point?
270. 270.
Yeah,
It's
270.
0, 1.
So
Minus 1. Yeah.
what is cos 270 and what is sin 270?
Cos 270 is 0. And sine 270 is minus 1.
This thing clear? Now we have discussed the
Mm.
graph of sine and cosine.
First is cos, second is sine, yeah?
Yeah, the x
Okay,
coordinate is
yeah,
cos,
yeah, yeah,
y coordinate
okay,
is sine.
yeah,
Now we have discussed uh, some of the properties of sine and cosine, right? Also, there is
yeah.
there's more important properties like that you should have in mind. I think I have made you write these. I'm writing it again. Okay. So have these properties in your
Okay.
mind. So remember these properties. Now, how do you remember these?
All of these?
All of these will be used while solving trigonometric equations. Okay?
Okay.
I tell you.
Okay, okay, one
There is
second.
you can
Yeah.
memorize this. You can memorize. You don't have like there is a trick as well. You can understand it from the unit circle as well. Now, how would you understand it from the unit circle? For example, uh, just one first of all the trick, the thing that will help you understand it. If it's 180, okay,
Okay.
then then it will either remain the trigonometric ratio won't change. For example, there is 180, wherever there is 180, it's sine on the both side, cos on the both side, right? Whenever you see 180,
Yeah.
right? Whenever you see 90, it changes. If it's a 90, then sine becomes cos. If it's a 90, cos becomes sine. If it's a 90, sine becomes cos. If it's a 90, cos becomes sine. That is one thing. Okay. Now, what you have to keep in mind is in which quadrant, which trigonometric ratio is positive and which trigonometric ratio is negative. Okay. Now, the first quadrant,
Okay.
the first quadrant, in the first quadrant, what's the position? First quadrant, what is positive and what is negative?
All are positive.
Yeah, both are positive, right? So here is the sign of
Yeah.
positive ones. Here is the sign of.
Tan as well?
We are not. We have not written tan in the formula, right? Yeah, tan
But
will
but
also.
is it positive?
Yeah, it is positive. Tan is nothing but the
Okay.
ratio, sine over cos. So if either both are positive or both are negative, then tan will be positive. If it's ratio,
Okay.
right? It's ratio of sine over cos. Tan will be positive when both are either positive or both are negative. If one of them is positive and one of them is negative, tan is negative. Okay? You can find out tan when you can
Okay.
find out sine and cos. Now, so in the first quadrant, both are positive. First quadrant, sine is positive and cos is positive. The
Yes.
second quadrant, tell me what is positive and what is negative.
Mm,
We have discussed this like this is the third time we're discussing this.
yeah. It's co what's this? Cos is negative.
So it's negative because it represents the x-axis, so it's writing it inside the negative column. And sine is positive.
Yeah, and sine is positive.
Yeah, what will
Yeah.
tan be? What will tan be? Positive or negative? You can tell.
Mm, negative.
Negative because sine over cos, positive or negative, it's negative. In the third quadrant,
Okay, okay. Minus one, and then so it's negative, negative, tan positive.
sine is negative. Sorry, negative, negative. So both are negative, right?
Yeah.
Both are negative. Sine and cosine, both are negative, and tan will be positive. Good. In the fourth quadrant,
Yes.
the fourth quadrant,
It's positive, negative.
What is
Cos
positive?
positive,
Cos is
uh,
cos is positive, sine is negative.
sine negative.
One thing. Now, sine
Yeah.
180 minus theta. So 180 minus theta. You have to keep this in mind. So 180 would be like this. This is 180, right? This is 180. Yeah?
Yes. Yes.
Minus theta. It will be
Yeah.
somewhere here. So in which quadrant are you if you do 180
Okay.
minus theta?
Two.
So in this quadrant is sine positive or sine negative?
Positive.
That's why it's a positive sine theta. That's why sine 180 minus theta is a sine theta. It's positive sine theta. Okay?
One more time. So, like, what is sine, sir? Like, sine is just the y-axis and cos is just the x-axis,
Yes. So sine
and
180
the
minus
angle between them is theta.
the angle between the x-axis and the line that is moving, this line that we are moving along the
Yeah.
circumference.
Then what is tan?
Tan is the ratio of those two values.
Like
Y
just them divided.
Yeah, just then divided y over x.
Like, is it on the graph somewhere that's visible?
No, it's not on the unit circle that you can visualize.
Okay. Okay.
So 180 would be like this, right? It is 180 like this,
Yes.
and minus theta it would be like this. So you are still in the second
Yes.
quadrant, right? In second quadrant, sine is positive. That's why it's a positive sine theta. And I said for 180,
But
the
cos is negative.
cos is negative. Why? Because you are in the second quadrant. That's why you added a negative here.
Okay, okay, okay. We're making different formulas.
Yeah.
Okay.
Now, sine of minus theta.
Okay, so for the next quadrant, the formula is minus theta.
Sine of
Minus
minus theta.
theta.
No,
Okay.
plus theta is measured like this. Minus theta would be measured
Goes
like
down.
this. Yeah. So we are in the fourth quadrant. In fourth
Okay.
quadrant, sine is positive or negative?
Hmm. Sign is positive, negative.
Negative. That's why a minus sign is here. You can see.
Okay.
Now, cos of minus theta. In the fourth quadrant again. Now, cos of minus theta. Is in the fourth quadrant is cos positive or negative?
Oh, sir, these formulas, we just have to remember like the cases and just put sine or cos.
Yeah. And you just have to remember the
Like
sign.
example 180 minus theta, we do it with sine and cos,
Hmm.
and then we just have minus theta.
Hmm.
There's probably plus theta as well.
Yeah.
Okay.
There is this plus theta. 180 plus theta. So you will be in the third quadrant, right?
Yeah.
180 is here and plus theta will be in the third
Okay.
quadrant.
Okay.
And both since
Starting to understand.
in the third quadrant it's negative, right? That's why you added a negative sign. Here it's also negative.
Okay.
Okay.
Yeah.
Cos of minus theta is cos theta. Is it clear?
Yeah.
Now,
So we have six cases.
six cases. You can have infinitely many cases actually. You just have to learn how to move on the unit circle. Okay.
Okay.
You can have like
Fine.
360 plus theta, 720 plus theta. And they are all going to give you the same result because it's
Okay.
360 is one complete rotation. Also, if you have like
Okay.
even
If it's
multiples of
plus, there's also minus.
yeah, if there is plus, if there is also minus.
Even multiples
No, no,
of 5.
odd multiples. Like for example, 90. Okay, not 180. I'm talking about 90.
Okay.
So it means it is nothing but pi by 2.
Okay.
Even odd multiples of pi by 2 plus theta. Or if it's 3 pi by 2 plus theta or minus theta. Okay,
Okay.
then what happens? The trigonometric ratio changes from sine to cos. That's what you have to remember. And when it is pi plus theta or pi minus theta, it doesn't change. When it is pi plus theta or pi
Okay.
minus theta,
Okay.
it doesn't change. That's what's important. Okay.
Yeah,
Now sine 90 plus theta.
understood.
Sine 90 plus theta. You will be in the which quadrant? 90 plus theta.
Sine 90, first quadrant. Plus
Plus
theta, second quadrant.
in second quadrant, sine is positive or negative?
No, no, no. Yeah, second. Second quadrant sine is positive.
That's why it's a positive cos theta.
Okay.
Cos 90 plus theta. Which quadrant you will be in?
Cos 90. Cos. Okay, second quadrant, it's negative.
So that's why it's a minus sine theta.
Why is it sine?
I said you like if it's 90, then the ratio changes. If it's actually odd multiple of pi by 2, odd multiple of pi by 2, the ratio changes from sine to cos and vice versa. Okay. So if it's
Okay.
90 or 270, then it changes. Okay. Just remember. And if it's 180 or 360, then there's no problem. Okay. So it has to be a multiple of
Okay.
180, or you can remember it like this. If it's a multiple of 180, then the ratio doesn't change. Otherwise, it changes. Okay. If
Okay.
it's
Okay.
90 or anything else. Okay.
Yeah, I didn't notice that when you wrote it down.
It's
Okay.
if
Understood.
it's a multiple
So
of
where am I gonna use these formulas, sir?
in the second book. In the second book.
Okay.
Ratio doesn't change. So you can solve this up, right? If you like you understand this logically as well.
Possibly.
Okay.
Yeah, somewhat.
You just have to move your
Because I have to solve some questions to understand it fully.
okay, sure, sure. Now, for example, okay, let's see. This was trigonometry. Okay. Now let's understand the graph. Or okay, let's see the question from the second book first. Then we will see graph. So something else. Just a second. They sent me
You
two.
have like three girl students?
No, two. Actually, one.
Two. Oh yeah, one left.
Yeah, one left.
Oh, one.
So
Okay.
like all of them were.
And what about the other guy? Like, which grade are they?
One is like 1 year senior than you. He like
Okay.
studies computer science. One of them is like ninth grade. One is one is a girl that's in the
Okay.
same grade as you, but she has taken physics.
Okay. All of these people live here?
Yeah, in Dubai.
Okay. Anyone from my school?
Didn't ask your school. Maybe your is Apple
Mm,
International, right?
okay.
Yeah, I
Yes.
remember it from the word Apple. It's not an Android.
Yeah, I'm pretty sure. Thing is, when I first my mom told me about this school, I was like, "Wow, I'm joining a school that's created by Apple. Crazy.
Yeah,
It's terrible school.
it's terrible.
Even if this was the only school on earth, I wouldn't recommend it.
Right. Let's see.
It's
This is
terrible.
terrible. Uh,
Okay.
this, like, seeing this,
Okay. Yes. Which question?
these questions
Okay.
using the results, you have to show that sine 90
Yeah.
minus theta is cos
I've never understood them until now. Okay. Do that.
hmm?
Sine 90 theta minus theta is cos theta. Okay. I have to show them that. Should I draw a unit circle?
Let's see how it is. It is asking you to do this using the graphs,
Or
using the graphs of the
I
function,
can input theta. Okay,
using the graphs. What
sure.
what we did is we proved it by unit circle, which I think is more you know logical to me. But we can do it using graph transformations as well.
Yeah.
We can do it using graph transformations as well.
Okay, okay.
So we'll do it.
Like the f of x,
Yeah,
that one.
yeah. F of x plus a, f of x minus
Okay,
b. Like if you know how to draw cos
okay.
theta, you should be able to know cos of minus theta. It's like f of minus x, drawing f of minus x. Remember? If you know drawing f of x,
Cos theta is the y-axis is equal to cos of negative. So it's the inverse, like the opposite. All the points are becoming
see, this
negative.
is see we are not. This is not a graph of cos theta or sine theta. It's a unit circle
Okay,
understanding of the sine and cos. The graph is actually wavy, right?
okay.
Now we have these values. Let's draw the graph first of all. Graph is like you input the values of theta and the value of output cos y cos theta changes. For example, let's draw the graph of cos theta first of all.
Well, it's funny how it took the line as well, the border,
What?
like the image you're moving around.
Which image?
It took the border as well.
Oh, yeah.
Yeah.
Hmm. So cos of 0 is 1, right? So we will start moving from here. Cos of 0 is 1. So let's draw. So we know the values will vary from 1, minus 1 and 1. So let's draw these lines. This is not a graph. This is not a part of graph. This is just for me to like,
Yeah, just to measure the points.
yeah. Now cos of 0 is 1. So at 0 it's 1. It's here, right? Cos of 90 is 0.
Okay.
Now 90, maybe let's draw 90 somewhere here. At 90 it's 0, so it must go like this. At 180 it's minus 1. So 180 is minus 1. 180 might be somewhere here. So let's say 180 somewhere here and
Hmm.
minus 1 is somewhere here. So 180. And it goes like this.
Okay, 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 okay. Understood. Understood.
No, this is at
And
0.
each half represents the 90. Like it keeps adding 90. No, that's not 180. Didn't you say 180 was down?
Sorry. So this is 180.
Yeah,
This is 270. This is
yeah.
360.
360.
And
Yes. And then
and this is this
5,
is this is minus 90.
420. Okay. Minus 90.
This is
Minus 180.
minus 180. This is minus 270.
Yeah.
Now, as you can see,
Yes.
it is also, you can also verify this. Cos theta is indeed is equals to cos of minus theta. See, cos 360,
Was theta? Yeah. Yeah.
cos
Yeah.
360 is 1, cos of minus 360 is
They
also
both
1.
are the same.
Yeah, because it's a because cos
Yes.
is a symmetrical graph about y-axis.
Yeah. Because you explained the unit circle, this is much more easy to understand now.
Okay, and this type of function, which is like when you don't when you change the input parameter and it doesn't change, what kind of this function called? Remember, you don't. It's the same. Like you change the x from like
Same.
cos of theta is the same as cos of minus theta, or you can say that f of x is the same as f of minus x. What kind of this kind of function
Yeah.
is called?
Yeah. You told it to me. Wait 1 second. I'm trying to remember. Uh, even function.
Even functions.
Yeah.
Even functions are symmetrical about y-axis.
Yeah.
Now let's draw this graph of sine.
Okay. So sine should be uh so,
So
so
it's 1 sine of phi
zero
equals to 1
one.
sine. Okay, now draw sine.
Yes, sine is 1.
So sine of 0. Let's start with
Okay.
0.
So if this wavy graph has a unit of 1, the top and bottom is both 1
Yeah,
on the y-axis. Okay.
1 and minus 1.
Yeah, 1 and minus 1 there.
So sine 0 is 0.
So 0, yeah,
So start with here 0 comma 0.
from 0.
Sine 90 is 1. Now let's draw the graph in scale. Like 90 is here, so we will draw 90 here as well. So that this is 90, right? This is 90.
Yes.
So we will draw in that line. So maybe somewhere here, yeah. So sine 90 is 1. So the point
Okay.
is, so and sine 180 is 0. So 180 is somewhere. Yeah. Okay. So join now sine 270 is
How does this graph start?
this one. Huh?
Oh, it goes up and comes down.
Yeah.
Okay, okay,
270 is minus
okay,
1.
okay.
Like, so so it goes like this.
Yeah, okay.
And 360 is 0.
Does tan have a graph?
Huh?
Does tan have a
Yeah,
graph?
try all this value. Every function has a graph.
Okay, so it's starting from like the middle or something?
I'll explain.
Okay. Actually, it's starting from the middle.
Starting. Huh?
Yeah, like like how the first graph, the cos graph, is starting from the top, and the sine graph is from 0. So I was asking from which side does, like, where does tan graph start from?
I'll explain. It's not like this. It's not wavy. Like
Okay.
it's a periodic graph. It's a periodic graph. It's not trying to. Okay. So here what happens is this is 0,
Oh, oh yeah, tan graph. Okay.
this is 90. Okay. This is 180.
Yeah.
Um, this is 270.
270, 260.
This is 360. This one is 360.
Yeah.
Yeah. Now the difference between this graph and this graph, can you see a difference?
Yeah.
There is really slight difference. This is the graph of sine,
Okay.
and this is the graph of cos.
Okay.
You see, this graph and this graph is the same. Just what the yellow graph is just a shifted graph. It's shifted towards a right.
Yeah.
It is shifted towards right
A bit.
a bit by
Okay, it's
how much?
shifted by 90.
By 90 degrees. That's why sine 90 shifted right by 90 degrees. 90 plus theta is cos theta. That's why.
So, oh, sine 90 plus theta. Okay. Okay. Okay.
Or you can say it's shifted left by 90. The same thing.
Uh, which one is shifted left? Okay. Yeah. 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 It shifted left by minus 90. Hello?
Yeah, hello. Sine 90 plus theta, we
Yeah.
can just say sine theta plus 90. The same thing, right?
Okay. It shifted left by minus 90.
Yeah. So,
Okay.
okay, let's do it. Let's try to understand it better.
Also, sir, why do you change the time of the class?
What do you want the glass time?
No, you changed it like you postponed the class.
Because of Friday. Today was Friday.
Oh, the prayer.
Yeah. Yeah.
Okay,
So if I
it's
draw
nice.
sine x, this is sine graph of sine, right?
Yeah,
Now here it is in radians, so don't get confused. It is in radians. That's why you're seeing 1, 0, and 2. We are drawing in degrees. So
yeah.
and let's say there is another graph, just cos of x. But focus on the red graph and the blue graph. It's the same, right? It's just the red graph that's it's either shifted. If you shift the left graph a bit left, yeah, then you'll get to
Which
the
graph is faster?
it's the same graph. How can I say faster? It's the same thing, just one is shifted left or right, whichever perspective you want to see it like.
Okay, so it's equal.
Not exactly equal. I mean, say the nature of the graph is the same, but one is shifted. That's what I'm saying. The sine graph goes like
Okay.
this, and the cosine graph goes like this. Okay. So you understand this, right? Sine theta plus 90 is cos theta. It means you're shifting it by 90 degrees towards the left. If you shift this graph towards the left by 90 degrees, this will become the cosine graph.
But sir, cosine function is faster.
Like, how do you want to call it faster?
I just searched it on Google. It says yeah.
Like, what's
The cosine is more symmetrical than sine function and has more uniform rate of change as x increases or decreases. And another way to see why cosine function covers faster than sine function is to consider their power series expansions.
mm, what do you mean by faster?
Like, which moves faster?
Both are moving
Like,
same.
when you input values,
Hmm.
like, one starts at a different side and like a different area.
Okay, so you're saying like if you are inputting the values, which one acquires the value faster? Yeah, that's what you're saying,
Yeah.
right? It depends. It depends in which range you are in. For example, you start with zero. Yeah. So
Example,
cost
it's infinite the range.
first of all is
One is one is going to be ahead of the other, yeah?
yeah, one is going to be sometimes sine is going to be ahead of cos. Sometimes cos is going to be ahead of sine,
Depending on.
depending on which angle you are at, depending on which quadrant that you are at. For example, you see the blue graph and the red graph, right? As you can see,
Yeah.
in the beginning, the blue graph is a higher value. Now it is coming down,
Okay.
and the red graph is at a lower value and it is going up. At this point, both are equal, which is
Okay.
45
Okay.
degrees. Now sine values acquire a bigger value, and cosine value acquires a negative, like smaller value. So now it goes to negative. However, now at this interval, in this interval, sine is greater than cosine. Now here they both become equal. Now cosine is bigger than sine. You cannot say like one is greater
Okay.
than the other. Like
Okay.
it depends
Fine.
on which interval you are in, which
But I
angle.
would argue that cos is reaching faster because you can see from the graph you're showing me, yeah,
Yeah,
that cos goes down and breaks out of the thing first.
let's sort of the thing first.
Like it goes above, yes, above
So in this,
the line.
you're seeing in this region, right?
Yeah,
Like it
just
just
in the first wave.
yeah.
Yeah.
Now see from here. Now see from here. Like you cannot like start with zero. Who says you have to start at zero? To see from here.
Okay. Okay. Makes sense.
Basically, both are the same nature of graph. Just one is just shifted towards the right. Okay.
Okay.
Like think.
Oh, okay. There's a more detailed explanation. It says cos leads sine by 90 and sine lags cos by 90.
Yeah, you can say that, but it's not the lagging. It's not that lag. It's not that lag. Like it.
Yeah, yeah.
Yeah. It's not like it's greater. It is greater or it gives you a higher value. It's like it starts when you think of starting here, right?
Mm,
So cos leads sine by 90, right? The sine is acquiring value of 1 here, but cos acquires value of 1 here,
yeah,
right?
yeah.
So that's why it leads, you can say it leads by 90. Okay.
Okay. It's cool.
Now just don't forget these graphs ever. Okay, now you can prove these properties like right over here by just the nature of shifting graphs. You have to prove that sine theta is equals to minus of minus sine theta.
Using the graph
Yeah. So it's basically asking you, if I gave you a graph here,
sine theta. Yeah, it is equal to that.
this is the graph of sine theta, right?
Yeah. They have a equal distance, you can say,
Which,
and
which
in the
distance?
positive and negative range.
What?
You like pick any point, and the positive and negative will have the uh a range. Yeah, like
Talking about graph
uh,
of sine or cosine, first of all.
the question is asking sine.
Yeah.
If we go 90 positive and then negative, it makes zero.
Hmm. But it is
So
asking you
it's
to verify that this is nothing but sine theta. That's what it's asking, right?
minus minus cancels.
Yeah. From the formula, we know that sine minus theta is nothing but sine of minus theta is minus sine theta, right? And this minus minus cancels,
Yeah.
so it becomes sine theta. But they are expecting you to prove it through the graph transformations. Okay. Now,
Okay.
how will you prove it through the graph transformation? You already know the graph of sine, right? This is the graph of sine theta.
Okay.
Sine of theta. Now, what is the graph of sine of minus theta? How will the graph of, so it's like f of x is given to you. You have to draw f of minus x. How do you draw that?
All the it goes like wherever it's up, it's down. Whenever it's down, it's up. It's
Yeah.
the inverse.
Reflection about which axis?
Like all the
Reflection about which axis?
x-axis.
That is what minus f of x. This is reflection about x axis.
Okay. Like I mean, it goes like you can draw a line. It goes up and comes down.
You're saying that reflect it like this. That's what
No,
you're
okay,
saying.
it goes down. Yeah,
It's
yeah,
you're saying reflect this thing as this when you are
yeah,
making this. Is that what you're saying?
yeah, yeah.
No, no. Th- this
Okay.
makes reflection about y-axis. I told you in the previous class. Reflection about this is reflection
Yeah.
about y-axis. So you have to make this as this. This thing is this thing reflected. However, in this case, both of them are going to be equal, so it will not matter. Like
Okay.
even if you draw it like this,
Yeah, it's even
yeah, because it's not even.
even function.
No, it's not even. Sine is not an even function. Wait,
So what is it
wait,
called?
wait. First of all, graph transformation revision.
Yeah,
Suppose this is f of x. This hump is f of x.
yeah.
Draw minus f of x. What will you draw? Tell me.
It's it's on the fourth quadrant.
It's on the fourth quadrant, just a reflection of this thing,
Okay.
right?
Yeah,
Suppose f of x is now the same. It's the same. Draw minus f of x. F of minus x. Sorry.
f of minus x.
Yeah, f of minus x now.
Sh- should be the same.
See, I took an entire class explaining this, and you're saying again the same thing.
Why is the mirror? Okay.
Why is the mirror?
Yeah, it should. Yeah, it should be on the second
Because the values that are
quadrant.
here, the values that are acquired at x will now be acquired at
Yeah,
minus x. So
yeah,
if you are achieving f of 2 at x equals to 2, you will achieve f of 2 at x is equals to minus 2 here.
yeah.
That's why. So
Okay.
it will be like this.
Yeah.
There's a difference, right?
Hmm.
Okay. Now
Yeah.
here you're given to draw minus sine of minus theta, right? Now first of all, just draw sine of minus theta. Now again, this was the graph of sine, normal sine theta, just sine theta. Okay, so sine theta graph looks like this. How will sine of minus theta look like?
Okay.
Tell.
It's mirroring on the y-axis.
Yeah. So if it mirrors, so
S-
this hump will be like this, right? And this
Okay.
downward hump will be reflected like this,
Yeah.
and this upward hump will be reflected like here, and this downward hump will be reflected like here, right? Look at the blue
Yes.
ones, isn't it?
Yes.
Okay. Now let's draw minus sine theta. Let's draw minus sine theta. Let's see the difference. Now again, this is the original graph of sine theta.
Yeah.
So tell me, how will it be looking like? Reflection of
Is this basically minus f of x?
yeah, minus f of x.
So it's going to be this the same.
It will be reflected. No, the drawing that will be made, it will be reflected about the x-axis. So you this graph
Yeah.
now will become this. Previously, this was becoming this, but now this will become this. Yeah, the upward becomes the downward. In the previous one, the leftward,
Okay.
yeah, and now this will become this. This thing will become this. This thing will become this, right? Now the important point is like both are like the final graphs in both of the cases is the same, right?
Yeah.
It's the same. So it means that f of minus x is the same as minus f of x.
Okay.
What are these kinds of functions called?
Even functions.
Not even function. Even function was this. F of minus x is the same as f of x. This is minus f of x.
Odd functions.
Yeah, it's called odd function.
Really?
Yeah,
Okay.
odd function.
It's nice. Just guessed it.
Yeah. Okay. So sine is an odd function.
Okay.
Okay. Let's move ahead. No, we were not supposed to draw minus sine theta or sine of minus theta. We were supposed to draw
Yeah.
minus of
Sine
sine of
theta.
minus theta.
What? No.
Yeah, look at the question.
It just asks minus sine theta.
So it says minus of sine of minus theta.
Oh.
And you have to
Okay.
prove that it is the same as sine theta. So let's see. No, we have already drawn this, right? We have already drawn this. So
Okay.
let's erase the original sine theta graph so that it's more clearer to us. Let's erase this. Okay, let's erase the white graph. So
Okay.
we have got sine of minus theta, right? We have got sine of minus theta. We
Yeah.
have got sine of minus theta. This is sine of minus theta. No problem with that, right?
No.
Now, what we have to draw is minus of sine of minus theta. So we already know the graph of this. Now consider this as f of x. What you have to draw is minus f of x. What will you do?
Consider this minus
Yo.
of the minus.
So what
So is it the same?
this thing? This is the graph.
Just becomes
The
positive.
blue graph is the same as this, right? Now you have to draw minus f of x,
Yeah.
right? Now this is f of x. So what do you have to do? You have to do
Yeah.
the reflection
Yeah.
and about y-axis. Sorry, x-axis, and you have to draw it
Okay.
like that. Now this
Okay.
becomes the graph of sine. This red graph becomes the graph of sine theta.
Okay.
That's why minus of minus sine theta is sine theta. That's how you have to prove it through graph transformations.
Okay.
Get it?
Somewhat.
If there is confusion, ask me.
Somewhat. There is confusion.
What's the confusion?
So the question is asking, prove sine theta is equal to minus sine theta.
Minus of minus sine theta.
Yeah, minus of minus sine theta.
So we first
So
so
like why are you drawing minus f of x?
I'm not drawing minus of x. I'm drawing, considering this as f of x, I'm drawing minus f of x. Forget about this. I first
Yeah,
draw,
okay,
I
fine.
first drew,
So you drew the blue line is minus sine
no, the,
minus
the,
theta.
the blue
It's
line is
basically
sine of,
just sine theta.
no, the blue line is sine of minus theta.
What is sine theta? Oh, okay.
Forgot? There was a white line as well
Okay.
that was representing the sine
Y-
theta.
Yeah, yeah,
And
yeah.
from that I
Okay.
drew this.
Okay.
And now what I have to
Yeah.
draw is this. So if this is f of
Okay.
x, I have to draw minus f of x. Now for this we do transformation, we do
Okay. Yeah.
reflection about this.
Yeah, I forgot the white line was there.
So yeah, I give some attention. Don't forget like this. So it
Yeah,
becomes
this
again the
this
sine.
class is the most attention I'm giving.
Okay. So
That's why I'm not brain dead like last class.
yeah, yeah. That's yeah, that's true. We are not brain dead like the last class.
Yeah.
Yeah. So this is sine theta. It becomes the sine theta again.
Yeah.
Is there a confusion?
No confusion.
So like these, you have to do transformations and prove that to get back to the same graph and so on. Okay. Now
Yeah.
this chapter, like this exercise, is only based on the graph of sine and cosine. It does not discuss the graph of tan
Tan.
as of now. As of now,
Is tan
hmm.
when we overlap, can you go to the Desmos?
Hmm. Yeah,
Like, what
you
is tan? Like the overlapping of
no,
sine and cos?
tan is
Like the weird waves?
completely
Like,
different. This is tan, the green graph.
yeah,
It's not overlapping.
okay.
The green graphs are the tan.
No, I meant like, where it's connected between the red and blue? That's what I meant.
It's not like that, right? It's not
Yeah,
overlapping.
yeah, it's not like that at all.
This is tan. This is tan.
Yeah. Why did it change color?
Just select some random
Okay.
background. So
Can you try it one more time? No, like remove it and add a new bracket. Yeah.
tan.
Yeah. Okay.
So this is tan, right?
Yeah. How does this work?
How does tan work?
Yeah. Is it the gap of 90?
Yes, this a graph of pi. Like
Pi. P-I-E.
pi.
P-E-I. Okay.
Pi.
Okay.
So tan is an integral of pi.
Crazy how I forgot to spell pi.
It's just see here it's
Okay,
0,
okay.
here it's a pi.
Yeah, yeah. Wait, what? Okay, okay. It's 90 and then yeah.
It's 0,
Pi is
180.
90,
180. Pi is 180.
180. Yeah.
Yeah.
Pi is 180.
Since sine 180 is 0, sine 180 also
Oh,
cos 180 is also 0.
it
That's
it's equidistant with the distance of 90.
distance of 180.
Like example, if you half it, that's where the line cuts off. So it's basically you can think of it as an asymptote if you
Yeah,
put a line.
yeah, the asymptote, yeah. This is the asymptote which is at pi by 2, which it will never,
Yeah.
yes. It has not drawn the
Okay.
asymptote, obviously. Does not need to.
Yeah. It's a black square now.
I think I've zoomed out a bit too much.
Yeah. Okay.
Useless things.
It's trippy. Okay.
So yeah. So the graph of tan. I don't. For this exercise, you won't need the graph of tan. So let's. Okay. Let's learn it. Let's learn. But keep that in mind. The graph of tan
Yeah.
is nothing but the ratio of sine and cosine. Yeah, sine and cosine, sine theta or cos theta. Now, initially at
Equals
0
tan.
is equals
Yeah.
to tan theta. At 0, sine is
Mm.
0, right?
At zero, sine is zero.
Yeah. So the graph of tan is passing from 0, comma 0.
Okay.
Okay. Now, at 90, cos is 0.
Yeah.
The graph of tan will
Zero divided by zero is at one.
at 90 degrees. This is asymptote,
What is zero divided by zero?
undefined.
Undefined.
So,
Cannot be one?
no.
No, yeah, anything divided by zero is undefined. Okay.
At theta equals to 0, sine theta is 0, sine 0 is 0, and cos 0 is 1. Yeah. So 0
Hmm.
divided by 1 is 0. So that's why the graph will pass through here. When theta is 90 degrees, sine 90 is 1, cos 90 is 0.
Yeah, and cos zero
So 1 divided by 0, it's undefined.
is one. Oh
Undivided.
yeah, again it's divided by zero.
So
Yeah,
that's
yeah.
why at this it's undefined. But if we get closer and closer to 90, the value of cos will become closer and closer to 0. And if it gets closer and closer to 0, 1 upon closer and closer to 0 becomes greater, like becomes greater and greater, and it approaches infinity. The graph looks like this, and same happens on this side. The graph looks like this, and this is your asymptote. Sorry, this is your another asymptote at 90 and at minus 90. Okay, and now what you have to do is repeat this graph. Just have to repeat this graph forever. You have to repeat this thing again like this, and then graph.
Sure.
Yeah,
Do you have a calculator with variables?
calculator with variable. Yeah.
Like A, B, C, D? Well,
Uh,
what is it used for?
which calculator are you talking about? Is it?
FX 570 ES plus.
I have got FX 991 ES plus.
Okay, it should have variables like A, B, C in the above sine cos.
Yeah, it does.
Like, what is that used for?
Can be used to
When you
solve
press alpha and you press the number. Like, where do we use it?
alpha.
Yeah,
Uh,
you press alpha and
yeah.
then yeah. So how do we use this?
It can be used to solve equations. Like if you can go to the mode and there's one five, it's an equation. Okay. Here you are about to enter the value on. Sorry. Never used it. Never used it. I have to see. I don't know. Also don't know.
Okay, because do you have the thing called solve equal to on
Mm,
the first two words are left?
solve. Yeah, I have it.
Yeah, when I just randomly I put the variable
Mm,
and I put solve equal to,
mm,
just press calc.
mm.
It asked me a value of C.
Okay, okay, I understand. It is related with Jacobi methods. I've used it once in my life. So it
Okay.
asks you one value. Like if you give three variables to it, uh, then it will ask you one value. You have to put value of C or any of the variables A, B, or C. Like how many variables do you put?
I don't know. I just tried one because I never used this before.
So
Okay, C, D, E, and if I put calc.
it is use it can solve any equation like
Yeah, it's asking me
approximately
the.
approximately.
Oh, oh, that's nice. What is this used for though?
Uh, if you are interested, because it's not easy for me to explain in simple terms, go and search Jacobi method. Don't Jacobi method calculate.
Okay.
Just Jacobi method. Like,
Okay,
and
I'll search it
yeah,
myself.
and you can solve like determining the solution of a really, you know, any number of equations, like any equation, most of the equations which is linear, you can solve it. Like n number of equations there, you can solve it using that method.
Okay, to
And
find the. Wait, does this means I can use this in simultaneous?
you
No,
have to run the iteration at least 10 times, then it will give you the correct answer. That's the problem. It doesn't give you the
10 times.
exactly equal answer. It doesn't give you the answer that's exactly what the answer is. It runs the iteration and gets closer and closer to the correct value. That's the problem with Jacobi method. It is used to solve a system of equations which are not easily solvable.
Okay.
So if you use in a system of equation, you will have some error. Jacobi method using calculator.
Yeah.
So you can see this. Like someone must
Uh,
solve it using, yeah, he is solving it. Gauss Jacobi method. He's solving these equations using his
yeah.
calculator. So if you are interested, you can see it. Like
Yeah,
if
I
there are
am
like
interested.
10, 12 equations and you have to solve them, it's not humanly possible.
Okay.
Even if you have a calculator, it's not possible for you. But using this Jacobi method, you
Okay.
can solve it out. You can solve it out using the calculator. But the value that you will get is closer to the correct value. It won't be the exact equal. Your calculator might round it to the correct value, but in some cases your value might not be exactly equal to the correct value.
Okay.
See,
Okay. Fine.
he's using solve, and I also don't remember
The
how to
thing
use.
is, I just stumbled upon this right this second.
The thing is, I also don't remember how to solve it using the calculator. Yeah, you need calculator for that.
Okay.
For these things you need calculator.
Okay.
Uh,
Okay.
Any other
Thank you,
thing?
sir.
Okay. Well,
Yeah.
okay then. The homework is this, right? Given it. And are you taking
Yeah.
a class tomorrow?
If you
On
can
Yeah,
take.
I can take on Saturday and Sundays if you want it. Just
Okay.
call
No
them
problem.
or inform me. I can inform them.
What time are you free?
Tomorrow, anytime. Almost any. Like
Anytime.
except for
Anytime.
the time at the time you start time. Yeah, except for that time.
Okay. So.
What time do you want?
Okay.
What time
Okay.
do you
Fine.
want?
I don't know. I'll ask my mom first.
Okay,
Uh, and then I'll get back
yeah,
to you.
like you can contact them, right? Like you have your mom's number or something. Just
Yeah,
contact
I
them.
tell my mom to contact them
Yeah, okay, that's fine. Because we
because
just
I
don't have
lost my
WhatsApp.
phone with
Yeah,
the WhatsApp.
get in.
Yeah,
You have iPad,
it's
iPad,
terrible. It's terrible.
iPad,
Terrible.
iPad.
Terrible.
Don't iPad supports
Doesn't have.
WhatsApp, right?
Doesn't have.
Why?
No.
Really?
Doesn't have a SIM.
It doesn't
You
matter.
need
Like
a SIM device.
no, no, no. WhatsApp can run even in a device that's not having SIM.
Uh, no, I just searched WhatsApp and it's not there. I'm pretty sure
Like
because
I use
any device
WhatsApp.
that needs a SIM, like a
Mhm.
phone, yeah, it can run WhatsApp.
It's
Maybe
okay.
Android tablets might run WhatsApp, but
It's not on
I'm
the app,
1000% sure Apple doesn't. No, it's not on the App Store.
and
I
then
just
then
checked
I'm
to confirm.
not aware so much about the Apple ecosystem. Okay, maybe. Yeah.
Okay.
Okay then.
Thank you, sir. Take care. Bye bye. See you soon.
See you.